All right, welcome students. Today we're going to continue and we're going to talk about the structure of the atom, or not the structure of the atom, excuse me, the structure of the periodic table. Um, Now that we've dealt with the atom and understanding what the atom is, we're going to see some correspondence between the periodic table and what we've learned about the atom, and we've even been using our periodic table. So now we're going to kind of take a closer examination of the development of the periodic table and kind of how it ties in with some of the things that we've already learned, such as valence electrons or electron configuration. We learned about the quantum model and the different energy levels of where the electrons exist. Also, we learned about the sublevels, and so we're going to see how the periodic table kind of ties in with all of those different kinds of things, including some other ones that we're going to learn along the way. So let's get started. We're just going to quickly kind of whiz through this first part, and that is just kind of a history of how the periodic table was developed. And we're going to start with a guy by the name of Dobrynir. And before we get to him, and you guys are going to read about a lot of these guys as well, so I'm not going to go into a lot of detail. And the reality is, a kind of background before him, you had guys like Dalton and Antoine Lavoisier, who were involved in discovering basically what we would call elements today. I don't know if they necessarily called them elements to begin with, but they began discovering these new items. Dalton discovered almost, I think it was 60. And so you began with now you're having, as science is progressing, you're beginning to have clumps of all these newly discovered, what we call elements, even though they didn't necessarily know they were that. And some men began to kind of investigate these a little bit closer, and they noticed there were some patterns. And the first guy to do that was Dobrynir, and what he came up with were triads. And he saw that there seemed to be some relationship between groups of three. And we'll kind of, go over some of those, and as you read along in the book, you can kind of see. But in other words, groups of three seem to have similar properties, particularly physical and chemical properties. And so he began to arrange these in what we call triads. Now, eventually, some of these triads became tetrads and pentads, so his idea kind of eventually broke down. But he was on to something in that the idea that, hey, maybe some of these elements are similar to one another, and there might be a reason why. And we call this periodicity, is what the name we give to it, and eventually out of that, of course, eventually became the periodic table, but we weren't there yet. But he was one of the first to kind of really begin organizing the elements together. The next guy, unfortunately, was a guy who was mocked, and that is John Newlands, and he was an Englishman. And he actually was even closer than Dobrynir, but because his background was basically in music, what he said is he investigated, and he did do some scientific work, that there were 7 columns, and he came up with this thing called the law of octaves. In other words, every 8th element seems to repeat in terms of periodicity, and it has the same physical characteristics or properties and same chemical properties. And so he was noticing this repetition that every 8th element seems to repeat. So he organized that into what he called the law of octaves. He was kind of laughed out of the science hall because of his musical background, and they thought he was trying to take music and connect it to science, and they thought it was ridiculous. In reality, he was actually very, very close. If you stop and think about it, and we'll kind of make a connection here a little bit later, but we talked about that there's, how many total valence electrons can you have? Well, there's 8, and part of that's because once the s and p orbitals are full, what do? You go back to another energy level, an s, before you move on to a d or anything like that. And so there's every 8th one kind of repeats. There's a periodicity there. Now, the guy who is given credit for the periodic table is a guy named Mendeleev, and Dmitri Mendeleev. And he spent a lot of time and arranged the elements by their atomic masses, and this was something that had never been done before. And when he did this, he noticed a couple things. He also organized elements that were not yet discovered because he noticed there were some big gaps in some of the masses. And as he did that, he kind of put this all together, and he's actually able to predict some elements that were yet to be discovered and what their properties should be. And ultimately, he came up with more or less an organization to everything that we call the periodic table. And he came up the first version of the periodic law, which says that properties of the elements vary with their atomic masses in a periodic way. Now, this is not actually the modern periodic law, so this is not the one I want you to know or memorize because it's going to be modified. But it worked for the most part. And they had their first arrangement, and they noticed that elements seemed to line up underneath each other by physical and chemical properties. Things were working well, with the exception of a couple. And that's where our next guy comes in. Our next guy comes in and deals with what we call the modern periodic law, and that is Henry Moseley. And what they noticed was that Mendeleev's worked well for most things, but there were a few things that it didn't quite work well for. And if you lined it up by atomic mass, and they would actually be flip-flopped and out of order. And so he realized, well, instead of atomic mass, let's do it by atomic number, and let's see if that takes care of our problem. And most of the elements stayed right where they were. There were only a few that ended up kind of flip-flopping as a result of that, and they ended up in the right category with physical and chemical properties. And we'll kind of show that in class, kind of how that worked. This is the official periodic law, and it says that the properties of the elements vary with their atomic numbers in a periodic way. Periodic there means they repeat, okay, on a regular basis in a systematic way. Is kind of what we're referring to there. Now, in the periodic table, you have a bunch of elements, such as this one, uranium, and you just need to be kind of familiar with what are some of the things that are on there. And some of these you already know, like the atomic number in the upper left corner there. You have the symbol and the name, of course. You have the atomic mass. We've talked about how the atomic mass is a weighted average of all the isotopes. You have the electron structure by energy level. Yours and your periodic table looks a little bit different. Of course, you have the 1s2, 2s2, those kind of things on your periodic table. And so there's all kinds of information, and most periodic tables include some other things like the melting point and the freezing point of a particular element. Densities are usually found on there, and then on the back you can find even some other information. So there's all kinds of information that you can find on the periodic table. These are the main key pieces of information that you want to know on there. Now, there's kind of some important things as you go on the periodic table, and we're going to skip through all these here. Okay, so these are all the different key things to know. Now this one on the top there, radioactive, that's obviously only for uranium. It's not for everything. Now, first of all, on the periodic table, you'll notice that it has rows and columns. The columns are what we call a group or a family. And the reason we call it that is because they're related to one another, just like a family is related to one another, and they share similar physical or chemical properties. So that if you look at the far left there, column there that begins with hydrogen and goes all the way down, that what we call the alkali metals. And those metals share similar physical and chemical properties. And we'll kind of go through all the different families and give them names as we go through. We'll do that a little bit later this chapter. But that's what a column is called. It's called a group or a family, and they share similar physical and chemical properties. A horizontal row is called a period or series. And if you notice, there are conveniently 7 rows. Now, what might 7 correspond to that we've previously studied? That's right, 7 energy levels. And each row corresponds to an energy level. And so obviously the first row there is energy level 1. And you notice there's only 2 elements in that first energy level. That's because each electron, okay, hydrogen has 1 electron, helium has 2. Once that's filled up, Energy level 1 is filled up. And then you go to energy level 2, and you notice energy level 2 there, row 2, only has 8 elements. And then it's full. Okay, and then now once you get to 3, we'll talk about the 3D and so on and so forth there. And there's kind of some mess that you get into once you get into the Ds and how that's arranged as well. All right, here's the periodic table itself. And just a couple things I'm going to point out here using kind of a little laser pointer here. Here's the periodic table itself, and we're going to make a couple divisions here, but really what I'm concerned about, as we were just talking, you have your 7 columns, or excuse me, your 7 rows, and then your columns that are your families or groups. And like we said, this is row 2, and so row 2 would be energy level 2. There's a total of 8 there. Now, where it becomes weird, you'll notice here that starting in row 3, you notice these right here, sodium and magnesium. Those are 2 together. These first 2 rows would basically be your S's, your S sublevels. And so these would be your first 2 electrons here. These rows over here, starting with boron and moving across to neon and all those columns, okay, right there, that follow down from them, those would be your P's. And you'll notice you have 1, 2, 3, 4, 5, and 6. Okay, so those would be your 6 electrons that go in there. And then these columns here, what we call the transition metals, from scandium all the way to zinc, and those columns, any of those metals that are in those columns, that would be your D sublevels. Right in there. And then at the bottom, not that we'll use any of these elements here at the bottom with any regularity, but these would be your F sublevels. And you notice where they're supposed to be inserted in the periodic table. So you can actually use the periodic table to figure out where any particular sublevel or how many electrons you have and those kind of things. So if you were wondering, last chapter, how I was figuring out how many electrons something had so quickly, and what energy level, what sublevel it is, that's because you can kind of use a cheating method, and that is the periodic table itself. Will tell you that, and we'll kind of practice that a little bit more in class. All right, what else is true about the periodic table before we leave today? Well, the big division that you need to know, and you'll need to know this for the rest of the year, and this will be super, super important when we get to the chapter on bonding, because how do I tell what type of bond? You heard of covalent bonds and ionic bonds and metallic bonds and all those kind of things. How do I tell? Well, it depends what's bonding with what. And what we've got here is basically 2 major sides to the table. You have on the left-hand side what we call the metals. And by left-hand side, we'll show you in just a second what we mean. In the right-hand side are the nonmetals. And so those are the 2 major divisions. Metals on the left-hand side, nonmetals on the right-hand side. In the middle that are kind of on, they kind of share on both sides, they share properties of both, are what we call the metalloids. And I'll show you where those are in just a second. Now, where are these on the periodic table? Well, on your periodic table, and even on this one here, you could take a look right about here, starting with boron and going along here is this little stair step. To the left of that stair step, all these over here are metals on the left side. To the right of that stair step are the nonmetals. And then the ones actually touching the stair step there are what we call the metalloids. And you can kind of see that on your periodic table. The ones basically in green there, those are what we call our metalloids. Everything to the right, nonmetals, to the left, metals. It'll be super important when we get to bonding that you understand that, because when it comes to bonding, that's how we distinguish one thing from the other. And if we ask you for an ionic bond, well, an ionic bond is a metal with a nonmetal. A covalent bond is a nonmetal with a nonmetal. And so knowing where those things are and being able to identify on the periodic table becomes very important. And that will be something you will have to do on the test. All right, we're done for today.